Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're talking about yet another math topic with an intimidating name. That topic today is overlapping sets, but you probably know it more commonly as Venn diagrams. So let's take a look and see if it's as intimidating in material as it is in label. Okay, let's talk overlapping sets. So I'm going to mostly call this Venn diagrams today because overlapping sets just sort of feels intimidating, so we're going to try to keep it as simple as possible. And yet, just noting, different background for today, and probably this background will only be for this video and the asymptotes video, so you consider this a limited time collector's edition background. Anyway, focusing in on today's topic. So many of us have seen Venn diagrams in the past, but I'm just going to go ahead and define how they work here just to make sure we're all speaking the same language. So basically we have set A here. So it's the circle represents a set of things. And then set B here is another set. And then this here, this area is the overlap between those two sets. So in this instance, I've sort of done a silly example. My set A is all sports. So basketball, football, baseball, etc., highlight, whatever you want. And then over here is all vegetables. And what we're saying here is there is an overlap between things that are sports and things that are vegetables, and that thing is squash. So kind of a silly example here, but just illustrating how this works. You know, if we wanted to be more serious, maybe we go something like we have the set of all math teachers and then the set of all art teachers, and in here is the set of people who draw circles. I would say me being one of these on the left, but not so good at the drawing of the circles as perhaps the folks on the right here, but a circle nonetheless. So just another example of overlapping sets. Just to say that this instance here is what's the overlap. Okay, so moving on to our next drawing here. So it looks pretty similar to the first drawing that I made, except I've included this box here. And so if you see this box on the SAT or ACT, this is not a mistake. It's not just the format of the graphic. It's actually part of the graphic. So the way that we read this is, and so in this example, I've given us an instance where we have a chess club, a robotics club, people who are in both and people who are in neither. And so everything outside of the circles is neither club, because you don't have to be, you know, if these are the only two options, you could say no to both. And so we look into this problem, and here we're introducing a little bit of math associated with how to figure out what's the difference between the onlys, the boths, and the neithers. Because, first of all, they're saying that there are 15 students in the chess club, there are 12 in the robotics club, and there are 6 in neither club. And, you know, 15 plus 12 is 27, and 27 plus 6 is 33. And so this is an apparent paradox because we have 28 students in the class and 33 total here. But what we're not counting, or rather we're overcounting, is the fact that this 15 right here applies to all of this and not just this right here. So what that means is that the 15 here includes our in both, and the 12 right here includes our both. And so what that tells us is, well, how do we calculate the both? Well, it's the difference between these two sets added together and what we would have if we added them together completely. So the fact that there's a difference of 5 here leads us to understand that there are 5 students in both. And I'll introduce an equation how to calculate this in just a second. But if we tidy this up a bit, what that's telling us is that there's 5 in both because 15 plus 12 plus 6 is 33, and we know that there are 28 students, so our overlap is 5. That means that since there are 5 students in both, there are only 10 students that are only in the chess club and 7 students that are only in the robotics club, and 6 students that are neither. So if we did now 10 plus 5 plus 7, that's 22, plus 6 is 28. Now this distribution of students matches up with our class of 28 size. And so now stick with me here. I'm just going to introduce a little bit of formal logic and symbols here. So what I have here for this formula is P, and they have this U looking thing right here. This is the union sign. So the probability, or the set of like the A and the B, is equal to the probability of the A, the B, and then the intersect of A and B. That's what the N here is, intersect. You can kind of remember because this is a U looking thing. This is an intersect looking thing. And what this is saying is like all of the items that we're looking for is equal to the one plus the other and then minus the both. So in this instance here, that's 15 plus 12 minus 5. But rather than doing visually, now we're doing it with symbols. So the probability of the whole set is equal to 1 plus the other minus the both. And that's a very useful way to think about this because we don't want to be double counting in the instance of an overlapping set. Okay, and moving on, as usual, we have 2 example problems. Go ahead and take a look at this first one and see how you do. All right, let's take a look. So how many students attend this high school? Interesting. So a survey is done at a local high school about students' preferred extracurricular activities. The results of the survey are as follows. 50 students are in the art club, 60 students are in the science club, 40 students are in both the art and the science club, and 10 students are not in any club. So basically what we're going to say is we could, now let's just go ahead and write it visually. So we've got our Venn diagram. We have, first of all, let's say 10 are in no club. We have 50 students in the art club. And that's, again, this whole set. We don't know what the both is yet. And then we have 60 students in the science club. And 40 in both. So if we want to use our equation, basically we're going to say our probability of the union of the two is just going to be the first one plus the second one minus the intersect, which in this case is 50, 60, and 40. So that's just going to cancel out to 10. So we have 10, 10, and we're going to add our neither, which is going to leave us with 80 people in this tiny little high school altogether. Okay, moving on to our next one. Go ahead and try this one and see how you do. All right, let's take a look. So if there are 14 students in drama club and 9 students in sports club, and students can join multiple clubs, what is the greatest number of students that can be members of neither club? So the word processor here really wanted me to say either, but actually I really want to say neither, as in no clubs. So in a small school, there are 30 students in a senior class. Students can be members of 2 different clubs. You can be in drama or you can be in sports. If there are 14 students in drama club and 9 students in sports club, what this does here is it doesn't tell us how many the both are. We have to decide. So what that's telling us is it can look like this, right? And so what's our both, though? Well, if we're going to maximize one side, so we have people in the one club, the drama club, the sports club, and the drama and sports club. And then we also have the neither. And all that together is going to equal 30. If we want to maximize the neither, we need to minimize those that are in the club. And so what we can do here actually is decide that, well, they don't tell me, but let's say that everybody who's in drama club is also in sports club. So that's to say that there are only 14 students in both between them because it's a total overlap. We have 9 students in the sports club and then an additional 5 students in the drama club for a total of 14 students in the whole population. Then in the box outside of here, we only need to just add 16 to get to our 30. So a little sort of lateral thinking exercise here. Hopefully this makes sense, but I've certainly seen questions like this in the test where they look to see maximize one end or the other. And in that case, you want to say, well, what is the minimization of the opposite end of the set? Okay, that's it for this video. Like so many topics on this test, the SAT and ACT will not go into a ton of depth on overlapping sets, which is great news for you because if you just understand the couple of topics they test on it, then you'll be in great shape whenever you see it in context. If you found this material useful, we hope that you'll like and share the video and subscribe to Quad Education. If you have any tutoring needs, please reach out to us. Thank you for watching, and I hope you have a great day.